It's kind of cool.
That's a first. Okay.
Yeah, like it's not giving me the old runaround
Log
today.
in, do two-factor.
Yeah, and it's like go over here and do this, and but it's still thinking. Hold on, let's see. All
That's kind
right.
of cool. That's
Yay.
kind of cool. That's a first. Okay.
Yeah.
I
Okay.
hear my voice.
I know. I'm like, I think we're live. Let me make sure it shows up on the phone. Okay, there we go.
Yep.
30 we go.
Looks live to me.
Then I will bring it up on my phone so I can watch the if there's anybody in the chat, if anybody joins us, or if we're just talking to ourselves today, which is fine.
Oh, we should make a post if we haven't yet, unless Tanya's on that.
Yeah. Yeah, we could.
I made a post on the Facebook group at least, but I haven't shared it anywhere yet.
Okay.
Or the page, I guess I should say.
A page. All right. Oh, look, Justin's here.
What's up, Justin?
So there we have somebody.
Who took some pretty awesome Orion Nebula and Horsehead Nebula shots a couple nights ago.
Yeah, he did.
It
Yeah,
turned out great.
I haven't had a chance. Obviously, I haven't been in any of these chit chats the last like 9 days. He's kind of lucky that I've messaged him back about his workshop that I'm helping him with.
Oh yeah, that's pretty important, I feel like.
Yeah, it's pretty important. It should be fun. I've never been to Maine before, so this will be exciting. Yay! And then hi Jesse. We got a couple of people here. Yay! Welcome in. We're back this week. We took last week off because Tanya was out of town. Actually, she was out
Out
of
of town.
country. Yeah,
Out of country and off the
and,
continent.
yeah. And then I was at my first weekend at the auto show here. I'm still in Detroit, but we can manage this. So
And I'm
today,
just here
yeah, Christian's just
with no
here.
obligations for today.
Um,
So this
which
works.
which is funny he says that because we pretty much put this entire presentation on him. Since both of us are kind of a little loopy right now. Because we got somebody that's jet lagged, and then I've been on 10 days straight of dealing with the general public, so you can all imagine how that goes after a while.
And I'm just generally loopy on a day-to-day basis, so nothing out of the ordinary there. Do we
So
want to do presentation or current data first? I really
um
haven't checked into that yet.
you want to I mean we could start with the current stuff because we do that usually. We start with the current stuff.
Yeah, you're right. Okay, well, so
Let's
while we're
go.
there,
I gave you sharing powers, right? Yeah.
yep, I am in. So as of now, real-time solar wind data, really, there hasn't been a lot to talk about, if I'm being honest. Decent negative BZ for like high latitude aurora. So Alaska, I know the last, I think week has had some pretty amazing shows. I might have saw some things from
Yeah.
Canada. I want to say central Canada,
Um,
Alberta
there were
specifically.
some things in Minnesota and Wisconsin, I think, too.
Just the
Um,
horizon stuff, I'm assuming. I haven't
yeah, and
seen.
the bright moon kind of washed a lot of it
Oh,
out.
that's right. Moon
But
ruins everything.
but it was visible. So it's sporadic
Well,
activity.
I mean, at least looking in the last 24 hours, it's pretty clear why. We've got some pretty elevated solar wind. I didn't see much of a CIR. It seemed to just kind of gradually jump up into higher speeds and then some lower speeds and then higher speeds again. We're basically getting clipped, I feel like, by just parts of it and then parts of it.
Well,
But
yeah,
the point is, we've got oscillating BZ. So super nice for starting substorms, at least. And the most negative of them have been decent negative, and usually for around an hour to 45 minutes at a time.
so it's
So
not.
there's been decent substorming over the last 24 hours.
Yeah, do you have the picture of that? Because that coronal hole is an interesting looking one because it's long and
Yes. So going back to that one. So this is 3 days ago, looking at AIA 211, which all of SDO is back. In case you have not heard that yet, we are finally back in business. Which I'll be honest, I thought we were gonna at least be mid-year before I saw anything. So I was basically ready to give up the entire space weather gig. Anyway, yeah, it's a pretty nice and long one. And as of now, it is all just hitting the point where it should be geo-effective. So we're going to be seeing this for probably another 3 days, is the estimation. 3 to 4, I believe. Is that what Met Office said for the
About
forecasting?
2 days. So
Two.
yeah, we're about to lose the
We're
connection because
finishing it off.
yep.
So tonight might be your last night, which probably is not a bad thing with the wonderful cold we've all got coming into the actually, I think the entire country, if I'm not mistaken. We're expecting single digits tonight and negative lows for tomorrow. Well, Wednesday, actually, going into Wednesday morning. Looking forward to that.
Yeah. Canada decided to move in.
I mean, I'm not complaining. I haven't had a decent winter since I moved from Colorado, so I'm okay with this personally. Moving away from the coronal hole, we've got our sunspot look. I do have magnetogram info on top of that. So we've got white being positive, black being negative. It's peppered. I believe Justin said it was spotted, something close to that, and I would have to agree. Not a lot of potency, I would say, especially in the northern hemisphere. We've got a lot of these. I mean, that's kind of a bigger group, but they're mostly unipolar. Just a lot of positive unipolar areas. Some plages as well, which are just regions without spots. But then we have this region here. I'll be honest, I don't have the numbers labeled or anything, so I have no idea what the numbers are. This was looking pretty good as far as its magnetic structure was concerned. It's kind of fading now that some of the delta regions I saw there just 12 hours ago are gone. And it seems to be, though it's big, just a simple beta region now. I would barely be willing to give that a beta gamma classification. There's not much mixing. So I would not expect much flaring from that region unless it decides to change, which, we're in a lull for solar activity, so maybe. Beyond that, that's pretty much it. I can't say we have done much at all as far as solar wind. Again, it's just the coronal hole, which we're about to lose. No CMEs to talk of, although there was an eruption, so there's a small, tiny chance. Did I emphasize that enough? That something may come by, but it has been modeled as a miss pretty much everywhere. So I would not expect any of that. Oh, well, it's going to take a minute for this to reset itself anyway. There it is.
And there we go.
Right there on the western side. So it was a decent-ish eruption looking in the corona, but not much in Lascaux, and it seems to be pretty well away from the planet. So just mentioning it because it happened and it kills more time because we don't have a lot to talk about with the current data. So with that, we'll just jump into the presentation, which in this case was the solar coordinate systems. And I shouldn't say but some solar coordinate systems.
This will be fun to watch because I need to learn about this too. And I don't I think I told you in the chat. Oh, so the fire alarm went off,
Oh,
but it stopped. So I think so as I got all my stuff on to walk downstairs, I think we're okay. So that was
so fun
bizarre.
fact, we didn't hear anything either. So either you muted it really fast or Zoom just took that out
I
completely.
think Zoom took it out for the first because it went off a couple times and I was like, then I put it on mute, but it was pretty obnoxious.
Well,
Mm.
welcome back in that case. I'm glad you're not on fire.
Yeah, we're not on fire. Thank goodness. All right, anyway, back to coordinates.
Anyway, solar coordinate systems. Generally, so if you ever read Swipsy's reports on sunspots or anything of that sort, usually when they have events, and sometimes this is other groups as well, they will list the latitude and longitude address. So north 06, east 12. Those are just the general, we're going to call them viewpoint coordinates. That's because that's the label I have in HelioViewer at least. But there's many others. So why do we really need them? This is just a quick summary because we need to be able to say where things are. Just like all maps, they have to have an origin. You got to know where you're going. So in order to know where you're going or where you need to go to or where things are, you need to know what counts as 0, 0. What's your base origin there? So the sun, though, is just a big ball of plasma. And outside of the sunspots, which is the only thing we can technically see, there's nothing to distinguish. Is it up, down, sideways, across? Where do we mark the origin on this thing? It doesn't really make sense to label a blank ball, give it a 0, 0 point somewhere, and then, once we rotate it somewhat, we're going to lose that point. It's not going to matter. But there are a few different ways we can go about it. So starting from at least rather difficult to understand to most, we have the viewpoint coordinates. That is just as it sounds. It's literally take your solar disk, put a grid on it, and that's it. So you've got your 0, 0 point, and this is a video over one full rotation, which I want to say was back in August. I wish there was a repeat button on this thing, but the idea is you have your origin right dead center, 0, 0. Anything to the left of that is east, anything to the right of that is west, and you've got north and south. Pretty basic. So let's say you find a sunspot that you want to look at right there. Well, that's pretty much latitude -20, we'll say, and a longitude of 45 degrees west, roughly. So you can label it and you can tell somebody that they can go to this map and look at that spot based on those single coordinates. It's easy to know. It's constant from month to month. This doesn't change. Your grid is stable, and it's just easy to understand. But there are other coordinate systems that we would want to look at, or at least other things we would want to do to get more information out of this, because A, the sun doesn't stay stable. It's not just pointing up and down constantly. The Earth has a wobble and it rotates around the sun, which means the equator is going to be going up and down from what we're viewing. So there are coordinates for that.
It always
And I'll
gets
be honest, I just found out about them. This one specifically, the Stonyhurst
Yeah.
coordinates. This is basically the viewpoint coordinates that we had before, but it is based on, instead of the origin being dead centered of the disk, the origin is based on where the central meridian, so the middle of what we see as the sun's disk, meets up with the solar equator. And in this case, actually, that's kind of hard to see. I should have probably picked a
There you go.
better video for it, but in this case, you have a small wobble. So this center line right here, this is 0 degrees latitude. Note that it's stationary south right now of what the origin would have been in our viewpoint coordinates. So this is saying that the sun's equator right now is actually lower than what center disk would be showing. So that is what's labeled as the 0 degree mark there. Now, all of the longitudes are the same. They are fixed. So as you go through the sun rotating, it's basically the exact same as the previous ones. You just have a different equator. And over time, that equator will shift either further down or further up. I do have an example of that in JHelioViewer because this was a lot of fun to make. Also, for those of you that do not know and want to check out later, especially for those that are in JHelioViewer, if you go to the grid and enable it, there is a way to tell it what type of grid type you would like to see. So in this case, since we're already doing the Stonyhurst ones, and we're going to go back to 15 degrees, so it's not so busy looking. This is from, let's see, what did I do this one? Oh no, this is the Carrington rotation one, so it's this one I want. I did one from basically the March equinox of last year to now, essentially. The purpose being you want to see, so we are in February of 2024 right now. What we're looking at here, this is the sun's equator, which is now way north of the central line that we'd call the origin in the previous coordinates. This is going at about 1 frame every, what did I set it at? 2 days, I want to say. Yeah, 2 days. So every frame here is 2 days. It's 148 frames. I'm running it at 30 frames per second, so it's a little fast. But the idea is you're going to see the equator move down. You're going to hit the equinox roughly, and it'll go center, and then it's going, or sorry, the solstice, and then as it comes back down and hits the equinox again, it's going to stop right about there, and then move back up.
It really
So this
shows
wobble,
that
sorry, go ahead.
wobble. It really shows that wobble quite well.
So this is a full result of, again, the tilt of the Earth. At one time a year, we're looking at it this way. At another time, we're looking at it this way. The Earth isn't changing. We're just moving around it in a circle. So, or I should say an ellipse to be proper, I guess. Isn't that fun just watching all this too? And then you got these sunspots swinging around. Like,
Oh
anyway,
gosh, dang it.
is it going off again?
Yeah. Can you hear that?
Yeah, but it sounds muffled.
Oh, they're telling us. They're saying it's a false alarm.
Oh, good.
That's good because, you know, if your laptop blows up or catches on fire, this whole thing stops.
I wonder how many people actually went outside.
Probably everybody in the first floor,
Yeah, not me.
right? I mean, it seemed like you had enough time to get your coat on and get ready to go.
Yeah, anyway, that was obnoxious. Sorry.
Yeah, that's okay. At least we have some weird entertainment going on.
Yeah. But what I guess what's neat about this is it really can show you the whole Russell McPherson effect and like
Or
where
I get, yeah, why we're at different angles
why
relative
yeah
to the
why
sun's rotational axis. Yes, because, you know, the Earth is tilted. Well, so is the sun, at least in this reference frame. Oh God, how do I get out of this? Oh, there we go. I am lost. Oh, there we go. Sheesh. That was a weird way to exit instead of just going back to regular screen. Anyway, the point being, So it shifted. So you can see it basically as the equator moves up and down. This is over your point, but you technically, from day to day, it means they're a stable coordinates. So if you do a sunspot now and get its coordinates, and then 8 hours from now and get its coordinates, those coordinates are not going to change where they are relative to the sunspot. So it's easy to use, and it's easy to get an accurate tilt of where we are in the sun. So you can then make things called synoptic maps for these, which lays out the sun in a 360-degree fashion. Imagine unraveling the sun entirely into just a sheet of paper, and then looking at how the sun looks. Granted, we don't have any pictures on the far side now, so we have to assume once they leave the front side, it's all the same. But the idea is then we have an idea as to where the Earth is in line with some of the either sunspot regions or coronal holes or other features that may be of interest. And it gives us a better idea, especially when making models, as to how things are going to affect us or if they affect us. So I'm going to play that one more time. And again, the whole point here is just to note that the equator is off from what we call the equator in just your standard viewing coordinates, if we just made the center the origin. And finally, the other one. This is the more popular one that most people have heard of, but still might be a little shaky on what it is exactly, the Carrington coordinates. As mentioned, it is Richard Carrington. He's the one that also went through the Carrington storm that everybody knows about, of course, in 1859. He was very into solar physics and really solar astronomy in this case for years before that. In fact, we go through things called Carrington rotations, which is arbitrarily labeled when there is a rotation completely 360. Based on the fact that a rotation is 27.2753 days on average. We have our first Carrington rotation starting at number 1 on November 9th of 1853, so quite a bit before the Carrington storm, so he's been involved in this a while. But the idea is he decided, okay, what if instead we look at the sun and we lay out a grid on the surface of the sun and we say that all stays the same and doesn't move. So instead we have the Earth moving relative to the disk instead of the sun. Sounds confusing. Helps if you get to see a picture. Note the entire grid on here is moving with the sun as the sun rotates. So our 0 point is going around, coming back, and coming through. Also note that this is the same time frame as the last video, so the Stonyhurst coordinates. So the tilt of the equator is also present. So I like to think that the Stonyhurst is a mix of Carrington and the standard ones because you have the tilt, but it stays stationary, whereas the Carrington ones do not. So because the Carrington longitudes rotate, and again, this is a really weird perspective shift because from our perspective, we are staying the same and the sun is rotating. Well, this is saying, okay, let's make the sun stay the same and we're rotating around it instead. So that means everything is just stationary as to where it's at. This has the added benefit of making sunspot regions stationary compared to the latitude and longitudes, approximately stationary, I should say. They do shift a little bit, especially as you get towards the end of the limbs. It's pretty difficult to address the angle and the differences in the latitudes that rotate at different speeds. The equator rotates much faster than the polar regions. So to say that it rotates constantly as a solid body at 27 days, you're going to get some things that are off if you don't add that correction. But the idea is if we look at a sunspot region like we have here, probably should have done this at a much slower speed, but that's okay. I'm pretty sure I can do that here. We'll do 0.5. You have these longitude marks, 345, 330, 315, and you've got a sunspot starting to grow here. Oh, it did the quality back down to 360. No wonder it looks so bad. There we go.
That's better.
If you play it and track that spot, it stays stationary. So even after some time has passed, you have approximately the same latitude and longitude on the solar disk as you did before, even though that sunspot is changing. And now you've got it on the backside, and then you're waiting for it to come back, and now it's rotating around the eastern limb again. So the idea is it can give you a full picture, and you can lay out the sun, as mentioned. If you unravel the ball and just make it flat, you can lay them out in Carrington coordinates, and you can have a much cleaner picture as to where everything is. And to emphasize that point, Tanya brought a very cool video that I'm going to go ahead and share over from NASA. This is a Carrington map with multiple rotations put down from January 1st to September 27th of 2012. This would have been the first cycle 24 peak. which was honestly very uneventful. We got to the same sunspot number, I want to say almost a year and a half ago before the major first peak in cycle 25. 24 was a terrible, terrible cycle. Anyway, that's my opinion and probably many others. But the idea is you can then see what I'm mentioning as to, oh, I can't change the quality on that. Okay. As to it not moving. So remember in this coordinate system, the solar disk stays stationary, nothing moves. But the Earth, if we were to see where the Earth was here, the Earth would be shifting along with one of these lines somewhere in the middle. Or, I mean, it could be really anywhere here. But the idea is you can see all these changes. So we have some sunspot regions forming here. There's a filament about to launch right there. And it's doing that over, what was it, September? So 9 months of just changes. Now, the problem is pretty apparent, I think, here. You have, first off, some pretty bad distortion and almost, it just doesn't look right at all. Up above here, that's going to be about the 50 degrees region and higher latitude-wise. And again, that's due to mostly differential rotation. It is much slower up there, so trying to get the same data with making a photo in the center and then taking another one a day later and then another one a day later and then stitching those together, you're going to get more distortion in the polar regions because of that. It also is limited because we only have access to the front side, so we have to be creative and assume that once a region has rotated along the western limb, if you look at synoptic maps of the entire sun, or Carrington maps in this case, you have the backside basically staying the same. There are methods to gauge if there are new regions popping up or if old ones have disappeared. A lot of that is through helioseismology, a pretty cool field of science that I honestly know very little about. But it allows us to get a little bit of a better picture on the far side of the sun as to what's going on there. But that's one of the limits here we have. You don't really have access to the far side, so you don't know when this region has rotated around the western limb. And is it going to come back in the same spot? Is it a different spot in the same place? Did it maybe shift? What, like, basically, we don't know. That's another reason, at least in my book, another justification why sunspots, even if we know they're the same ones rotating for a second rotation, they get a separate active region number. It just
Yeah.
makes sense in this case. If we're going to relabel all the Carrington rotations, we should also relocate all of the sunspot numbers since we don't know necessarily how they changed on the backside. They could have shrunk to almost nothing and then grown and had some huge flux growth and become a monster. But would we call that the same thing? Is it technically a different one? We don't really know at this point anyway. So labeling them as different sunspot numbers makes far more sense. The idea is, though, once you do this, you have a little more abilities. If you've got a full 360 by 360, well, in this case, 360 by 180 look of the sun, you can go and put this into models, which is half of the WSA Enlil models we have to predict CME arrivals. Half of that, the WSA part takes in the Carrington, or puts things in as Carrington coordinates into the models themselves, which then they extrapolate and produce the solar wind out to arbitrarily amounts of solar radii outwards. And then once you get to the Earth, you can kind of see what theoretically would happen when a CME is launched. But the idea is this gives us a little more information, despite it being far less intuitive. You can see immediately just thinking in thought processes when you think of, okay, well, we're going to call this 0, and then every 27 days or so, we're just going to say it's at 0 again. There's a lot of issues with that, and you have to have corrections upon corrections upon corrections in order to make that work. And the more corrections you stick on something, the littler it's able to really predict anything. So really, we need some new tools, I would say. But this has been going around since 1800s, 1850s. So we are on Carrington rotation number, I know I put it in here somewhere. Did I not put it in here? Oh, I found out it was like 29,
Yeah.
2293.
I
So
mean,
we have had 2293 rotations since 1853,
it's
theoretically.
cool to have that kind of data to go back that far.
It is cool, and it's really beneficial that Carrington was so thorough in how his drawings, and he would do them daily anytime he could to get what sunspots were where. Otherwise, we wouldn't have anywhere close to a sunspot record during that. And then we can also connect the events that happened on that sunspot region and gave us the Carrington storm. That's generally all I have for the presentation itself, just to those basis, just to get those ideas out there. Do we have any questions or anything else that should be specifically gone over?
I don't see anything, so That
I know
just,
we kind of went on suddenly, but so I'm not expecting total amount of people on.
yeah.
But
But that
you-
means you taught it well. Yay.
or people are so confused that they don't know where to start.
Yeah. Or
That's
that.
the other possibility.
No.
Carrington maps are pretty cool
Yeah.
because of Carrington maps, we now know that there are preferred longitudes, which is probably
Yeah.
another topic. But sunspots are not, and coronal holes actually are not random. There are longitudes. We know that the latitude, so how far south and north they are, changes over the solar cycle. But it seems like they do prefer certain longitudes, and there are a couple of interesting papers on that. They do drift just a little bit because again, the differential rotation and the assumption that it's just basically 27 days, and it's not quite 27 days. It's probably average 27 days.
It is
But
27.2753 days, in fact.
yep. But nonetheless, it's kind of cool to have those maps and track the sunspots and track coronal holes. So there is use for every map, but every map will have its limitations.
All models are wrong, some are useful.
Yep, same thing.
I feel like it's very
Yeah.
accurate in this purpose here.
That should become what the motto, because it seems like everything in space, whether it's like,
I mean, we have two models, so it's that one and then L1 or bust.
yeah, it's like, oh, sure, but there's limitations.
Yep. Limitations, assumptions, and uncertainties. We live with them.
Yes, yes, that we do.
But
That
that's
we
the
do.
scientific method. It's what you
So,
got to do.
so hopefully everybody got a little bit of something. Because what's cool about going over kind of this more basic stuff is like it helps, like when you look at like a synoptic map, then you can make sense of how they're coming up with these numbers and what things mean on them. So it's
Yeah.
nice to have that kind of background, just to help you read things different. We'll have to go into the next, maybe then, because I know we were supposed to is like actually go over a synoptic, I can't say that word,
We
map.
could do that next on the next
Yeah,
one, just since we've got the basis of the coordinates out of the way, it might be like a natural progression.
yeah, because then
And coronal holes and active regions. So, yep,
yeah,
I think we are ready for that. And we can actually talk why flares seem to be on the limb, because they're
yeah, that's
not.
true.
As much as you hate that, having to even think that.
I know.
Yeah, that's very true. But that coordinate grid actually helps to see where the geoeffective region is and why it's not really all on the limbs.
Right.
I guess if you want to, I forgot I had this up already, just for the sake of
Oh
what a
yeah.
synoptic map actually looks like
Yeah.
for a Carrington rotation. These are three Carrington rotations from the start. The idea here is they're showing that the same region generally, how it evolves over three different cycles. So you've got a what looks to be pretty dense, and then it's spread out and almost gone, and then definitely gone here. And then you've got like some mild growth here, and then it's gone again. And basically that you can see comparisons. You can take this to this and go, okay, well, these are the changes I've seen here. So this is what it's gone through in a rotation. So this is definitely probably going to disappear. And then we've got some growth here. You can see some other scientific things too that I don't have the power to explain really when it comes to, well, really over time, the differences in the evolution of sunspots from higher latitude to lower. And if you do coronal models, you can see bright points as well over different rotations. But the point being, this is what would be considered a synoptic map, at least just in looks of a magnetogram.
Pretty neat. Pretty neat.
And that's all
Well,
I got.
yeah. Let's see. What is it? Models. Let's see. Do different models use the same data? Hold on, I'm trying to read through my phone here.
Well, it would really depend which models we're talking about.
Yeah, data, weight in different ratios. That was the end of the comment.
So it really depends which models we're talking about. So if we're talking about CME propagation models, so the standard enlil, how CME will evolve and propagate in space and either arrive at Earth or not arrive at Earth. Um, I would recommend watching actually Karina Alden's talk
I
on
guess she did one of
how
models, right?
CMEs, yeah, she went over how CMEs are mapped. So there is a lot of human factor that involved in mo CME modeling. They do use the same data, but in terms of how the cone, meaning how CME will evolve eventually, is fitted, it's all human. It's sort of approximation of we think this is going that way. So that's why maps, and that's why models of different agencies, even if they use the same model, they may disagree on what's going to happen with that CME. So that's pretty normal. That's expected, and it's helpful to know how different forecasters saw the picture, and it just gives you more information about how uncertain things are and what window of arrival is expected. And again, false alarms happen because sometimes we see things that are not necessarily end up being the case. So that's just kind of inherent uncertainty of the model.
And that
So
can
it's
go
not
as far
necessarily
down.
different ratio. Yeah, it's not necessarily that they weigh in different ratio. It's how the modeling, how the mapping was done, and those CMEs, how the footprint of that CME was mapped onto the magnetic field map. So
Hmm.
that's all.
I
That's
mean, you
all
can even
human.
have
That's all us.
disagreements on, so if say you've got a magnetogram Carrington map of a different rotation and you're putting that in the model and trying to create a potential field source, I always forget the actual acronyms, source surface for the model itself, you can have those even slight disagreements, which those slight disagreements will cause rapid differences. As we've seen before in the Hux models too, you put in a slightly different speed for the ambient solar wind coming in, and you're going to get huge differences in arrival times too. So it's, I mean, yeah, you really, it's not only it's the human aspect of it, but then even going all the way down to the base information we can get has some variability based on how it's interpreted.
Rock on.
All right. So I think synoptic maps might be the next one.
I like
Yeah,
that idea.
I will do that. Maybe we'll get something to talk about in the meantime, and then we'll get derailed again.
I
But
mean, I would love another geomagnetic storm. That would be sweet. Could use more
yeah,
aurora.
it's been a little quiet lately, so we could use something exciting.
Yep.
So anyway, those of you hanging out, thanks for watching as always, and hopefully you learned a little something today. That's our goal. We just want to keep building upon these things and
Education.
in little bite-sized increments of like a half hour because all of our attention spans are like this big now.
Facts.
So we will probably do synoptic. I will never be able to say that
That's a
word.
fun word, right?
Maps next week. So probably the same time at this 8 p.m. on Sunday seems to work for us. So
Yep, I
8
agree.
p.m. Eastern anyway. So until then,
Thanks, everybody.
right?
See ya.
Stay warm.
Yeah, stay warm. Oh, good Lord.